everyone, welcome again to my YouTube channel Fitness Speed Computer Game. So in the last lecture we are talking about arrays. We have done some question on arrays, like some Leetcode question on arrays. As you see, I've shown you actually how to approach this question, then figuring out what's the question required, then accordingly how to solve that question. So we have seen some questions like some easy mode question of Leetcode. So today's lecture is all about the extension of the previous one, where I will just solve some medium level question. I hope that you have done some practice of your own by referring to my easy level question and how to solve it. Actually, for easy level question, we have seen that so many questions were there, so it's very difficult to to solve every question. And the course itself will be too long. My idea is not to solve as many questions, but idea is to make you understand that once you're able to solve it, one question, then you can solve that type of question easily. So like easy mode question we have seen, you can solve it, have some idea that oh, this way I could solve it. Okay, so now we are approaching to medium level question. So in medium level question, not only arrays that will be involved, but some other data structure, some other approach may be involved that I haven't teach you. So for that purpose, I am taking a specific medium level problem that I have already read that oh, this problem can be only be solved by using array or some additional data structure which are very easy to understand, which are very easy in use. You might have used earlier also in problem solving. So considering those facts, I will solve some three questions of medium level, which is it will be easier for you to understand, and to solving array question it will be helpful. Okay. So without wasting any more time, let's hop into my Leetcode's website and search for the problem that I have especially selected for you guys. Okay. So you can see so many problems or easy problems are there. So that's why I'm just solving some three questions. If you have any doubt, you can ask in the comment section. Okay, I will solve those questions. Okay, there are so many questions. Now get into medium level question. The first question I would like you to solve, which will be this one, the original array of prefix XOR. Okay, let's see this problem. What's it saying? So let's see this question. What this question is saying? Let me explain this so that it's easier to read. Question is saying like you are given an integer array. You are given an integer array of prefix, like pre for prefix of size n. Find and return the array of size n that satisfy this formula. The formula is given like prefix of I equal to ARR of 0, XORing. This operator is for XOR, okay? ARR of 1 and so on up to I, like it denote the bitwise XOR, okay? It is proven that that the answer is unique, okay? They are saying like you cannot get it to answer, okay? Like the answer will always be unique. Now let's see the constraint here. See the constraint is 10 to the power 5 and the prefix array 10 to the power 5. Means 10 to the power 5 operation can be performed in one go. So in modern computer can perform up to 10 to the power 8. So it's saying that you cannot perform a double loop. Like if you take 10 to the power 5 and 10 to the power 5, then it will 10 to the power 10. So it exceeds the criteria of solving this problem in 1 second. So this problem is saying that you have to use only order of n solution. Order of n square is not acceptable. So let's see order of n solution for this problem. Okay, first. So as usual, let me just firstly let me just show you what is XOR. Then I will get into this. Okay, so like XOR is like what in XOR, like plus in mathematical, and in computer like bitwise XOR is like this. Okay, bitwise mean between the bits. Okay. So let me just start with the first this one. What is this so that you can understand what is XOR basically. So suppose there are two operand A and B, and we have to perform the XOR between them. So what could be the result? Actually, suppose I will write A XOR B. Okay. So it is a different one. So suppose the binary, in binary we know that if your number system to 2 bit, we can represent 2 to the power 2 minus 1, that is equal to 3 numbers up to 3. So it means 0, 1, 2, 3 you can represent using the 2 bits. 2 bits here represent like A and B. A is 1 bit and B is second bit. Okay. So 0, 0 it will be the first combination, and next will be like 0, 1. Next will be like 1, 0. Like okay, if you know the binary is easier. Hope you guys know this. So 0, 0 means 0, 0, 1 means 1, 1, 0 means 2, okay, in binary, and 1, 1 means 3, okay. Now you perform the XOR, and it doesn't matter if you don't know Excel, it doesn't matter actually. Okay, don't worry about it. So what could be the result here? So 0, 0 XOR, when you XOR 0 is 0 is actually 0. So XOR is, you can analyze this like, take a number like 0 and first do the, addition of those two numbers. Okay. Like 0 0 0 0 addition is what? Like 0 plus 0 is 0. And then divide this number and take the modulus by 2. Okay. It's also called a modulo 2 operator. That's why. So this is will be the result. Like, when you take 0 modulus 2 it will be 0. Okay. Now look at, okay, in this way I got 0. Okay, just remember that, just add on the 2 bits and then perform the modulus operation. Okay, after that. So 0 1 will be 1. Okay, 0 1 is 1 in decimal. Then 1 is, modulus 2 is 1. So this will be 1. Okay, then 1 0. If we take 1 0, 1 0 XOR is same as this. Okay, we will get 1 plus 0 is 1. Modulus 2 equal to 1. So it will also 1. And then 1 1. 1 1 is 2. Okay, remember this. 1 1 gives to 2. Okay, it will be 2. Like, 1 on binary also 1 0. It will be. But I'm taking a decimal value. Okay, and dividing by 2. So 2 modulus 2 is 0. Okay, it will be 0. So remember that. Whenever there is single one, it become one, and in the rest part it is zero. So, okay, you can remember this way, like same operator digit, then it will be zero, and different it will be one. Or you can, do the maths like this. Okay, if you want to know more, like, it's not a number system class, so but I'm still giving you. If you know some realization, like it is a b prime plus b a prime. Okay, this is the formula to get these terms. Okay, if you don't understand, forget it. Okay, no need for this class. Okay, just like what I can say, like, like A XOR B, we have seen like in the between the base operator. Okay, so in the same way, we can perform A or B in binary, in bitwise encoding also. Okay, so like suppose the A represent 4. So how are we gonna represent 4 in binary? So 4 in binary is equal to like 1 0 0, it's 4. And suppose B is equal to, 6. So how are you going to represent, or B equal to 3 or B equal to 6? Okay. Let's assume B equal to 6. Then how are you going to represent it binary? Binary is 1 1 0. Okay. This is 4. This is 6. So we're performing an XOR between them. Okay. So what will be the result of these two? Okay. When you perform XOR, what will be the result? You will, you remember that 0 0 is 0. If you remember what I am told you earlier, and 0 1 will be 1, and 1 1 is like 1 1 is 2, 2 modulus 2 is 0, so it will be 2 0. So it's binary representation 2. So what we get? We do A XOR B, we get a C, that is, 102. Let's see, and this number is like, this you can see, called it as C, and these are like, this is A and B obviously. So let's see what will we get by XORing B and C. Okay, so what we get in XORing B and C. Now B is like 110, as we all know. B is 110 and C 010. If you do XOR, what will you get? 110, 10 is 1, that is 4, and it is actually a A. So what we get? It follow, like three operator. Like, if you now get it, like, if you summarize this result, so what we get here? Like, we get A XOR B is equal to C, and B XOR C is equal to A. If you do also, like A XOR C, you will get B. Okay, this way it is followed. Okay, so using this rule, we will be able to solve this question. Okay, I will tell you later. Okay, let me now get into the details of the question. So we are given an integer array of prefix. So we are given this array, and this is the result of the XOR of this array. Okay, ARR of n XOR is performed, and this result is given. Okay, you can see this. Prefix of array is XOR of this. But we are given this array. We have to find the input array. Like, using this, we get this XOR. So what could be the input array? This question is saying that. Okay. So let me just copy this formula. So you guys here. So this is saying like prefix of I is equal to A XOR 0, A XOR 1, and up to I, whatever index is given. So now let me take an example, like this example. So this array is given, like this is in actually the prefix array. Okay, like this is the prefix array actually. So this is P of PREF. Okay, PREF is given, and we have to find the ARR. So PREF, you can see the XOR of ARR. So how can you find it? Okay, so this is the question. So how could you solve it? Like right now I told you, like A XOR B, like, you have seen that A XOR B is C, and A XOR C is B. So if you swap the operation, we will get the original array. Like, if you do A C XOR B, you can get A. In a similar manner, we can do this. Like if you do B XOR C, then you get O. Okay. So A XOR B is C. Suppose these are the input only, and we get the output. So we can do the output XOR with input also. Like this is the input, and we can XOR this one to get this part of the input also. So in a similar manner, we can do this. Like ARR is the output input array. So using this array, we are getting the output array prefix sum. Okay. This is output array. This is the input array. So performing this, we are getting is. So how we gonna get back to this? So we have to do the reverse thing. We can perform the operation between all these operator up to I, and we will get the result. Okay, let me show you. Like see, first is like a of 0. Okay, let me write it here. Just try to understand this one. Okay, very important. Like ARR of 0. First element is like what is saying ARR of 0. We have to do the same operation. So ARR of 0 will be like, suppose we imagine the ARR of 0 is 5. Okay, now ARR of 1 will be 5 XOR 2. We can do it this way. So 5 XOR 2 is what? To do this, 5 is like 0 1 0, and 2 is like 1 0 0 1 0. So 1 1 1 is 7. So we get 7. So we so so now you get it. The 5 XOR 2 is 7. Now if you do 5 XOR 7, then we get 2 or not. So you're getting it. So using these two, we can get this one, the input array. Okay. Hope it is clear to you guys. You know, like the same thing here. Okay, like 5 and 2 XOR is 7. So 7 and 5 XOR will be 2 or not. Means if these two are present in this array, we are getting this element or not. Up to I. I is here 1, means 0 1. Okay, hope it is clear to you guys. Hope you are understanding. It's very easy. We are just swapping this number. Here it's coming here, it's going here. So we can write 7 here. So next element of this array can be 7. Okay, you got it? Hope you got it. Now if you use these two, let's see what will happen. Like 2 XOR 0. 2 XOR 0, what do we get? 2 XOR 0 is 0 1 0, and 0 is 0. So we will get 2 only. 0 1 0. So 2 will be the answer. So if you do 2 XOR 2, then we get 0. So 2 can be the element here. Okay, if you're getting it, hope you're getting it. Now, what will be the next element? Let's suppose 3, and we performed XOR with 0. So next element, like suppose we have taken 3 XOR 0. 3 XOR 0 will be 3. So if we do 3 XOR 3, we get 0. So this element can be swapped by 3. Now the last two elements, let's XOR them also. So 3 XOR 1, what will you get? 3 XOR 1. 3 is like 0 1 1, and 1 is like 0 0 1. So what will we get? We get 1 1 0 1 0 0. So you can 2. So if you XOR 3 and 2, get 1. So this could be the element 2. So this could be the initial array. So if you do perform the array, you will get this array. Okay. Try to think. So let me show you the result first. See, 7 5 7 2 3 2 3. So now apply this formula that I've shown earlier, this formula. Apply this formula on this. Okay, we will get the final result. Let's verify our result. Okay, we are right or not. Very simple question, but yeah, it's some required some XOR skills. Okay, so let's do that. Erase this. This is array. So a of prefix of 0. First is the prefix of 0. We can see I element we have to find. Prefix of 0 is always a of 0. So a of 0 is 5. So 5 will be in 5. Okay, this is verified. These two are same. Now prefix of 1. Prefix of 1 is like ARR a of 0, like ARR I represent a, and a of 1. Okay, this is the formula we've given in our book. So a of 0 is what? See this 5, and a of 1 is 7. So what is the 5 XOR 7? So do it. Actually 5 XOR 7 you will get 5 is like 101, 7 is like 111. We will get 0 1 0. So 2. So 2 we are getting. So we are getting 2 here. So yeah, see this element is 2. It's verified. Now prefix of 3. What is the prefix of 3 result? Prefix of 3 will be a of 0. You know, sorry, this is 2 now. A of 0, a of 1, and a of 2. Okay. So a of 0 1 we are getting it is 2. So write the substitute with 2. And a of 2. A of 2 is what? 0 1 to this number. Let's XOR 2 with 2. What will you get? We will get 0. So verify this again. See, this 0 is not there or not. Okay, so we are getting it. Let me do the others also. Okay, you will have better understanding, right? Prefix of like 3 will be what? Now we will do faster, like prefix of 0 up to 3. So this result is already given here. What is this result? 0. So substitute this result with 0 and A of 3. A of 3 is what? A of 3 we have 3. See, there's 3 now. So 0 with 3, we XOR anything with 0 is always the same number. So we will get 3. So let's verify. Yeah, 3. And now the last prefix of like 4, the last element up to 3 and XOR with A of 4. Okay, up to 3 is like 3. Now 3 XOR. So what will you get? 3 is 0, 1, 1. 2 is 0, 1, 0. So we will get 1. Let's just verify this again. Yeah, 1 is there. So we are getting the result. So this is the way we solve this problem. So this is the approach, I could say. We can use approach here. Now let's see our solution. How are we gonna solve this? Okay, we have to drive this now in the formula. So we cleared that we have to find a prefix array with this output array using the XOR of input array. So if the output array is given, like this is the output array A1, A2, A3, suppose A3, A4, so on. It is given. So we are finding the element by by just doing XOR between the adjacent elements. So these two will be these two XOR. Firstly, the number is copied, like same number is copied. Then these two will be XORed. So what will be the result? A XOR B will be copied in the input array. Okay, we will make an input array. Here we will get A XOR 2, XOR 3, and this A XOR 3 and A XOR 4, and so on. So this is the array we are getting. So how to drive this formula? So it's actually what? It's actually we have to loop through it. So single loop can now work. Like you just have to run a loop through it. Okay, this is the solution. So we have to run a loop through it, like for int I equal 0, I less than the size of the array, and I plus plus. We have to run a loop. Then after running a loop, we have to just do XOR between these two, and submit an answer. So we have to take any vector, like vector int the final array, and like fin arr, take any array. So just what you have to do, we have to perform XOR and put the value. So like fin arr dot pushback. What are you going to push back? A of you have to run from 1. So A of I minus 1 XORing with A of I. Okay, this one you can push back. This is our final array, and just firstly take the value also. Like field ARR of 0 will be the A of 0. Okay, this take, and this is your answer. Okay, so let's now implement in code. Simple answer, a simple code. If you hope you guys understand this. Okay, let's now do the code. Switch it back. Okay, let's see. Let's solve the question. So what we have to do? We have to take one array. To take an array, vector int. We have to take final array. Put this one. Final array. Take it, and we just initialize the first value with final array equal to the prefix, first element of prefix array. But the first element will be same always. So now we've done it. Now we can run a loop, like for int, I equal to 0, I less than, let's take the size of this prefix element now, int n equal to pref dot size. Okay, hope it is clear to you. So I less than n, then I plus plus. So what's you gonna do here? You can do it one line also, but like fin array in arr equal to dot pushback. So I equal to 1. Remember this, otherwise the result will vary. So what do we do? Pushback. What do we have to pushback? We have to pushback prefix array of I minus one XOR with uh, prefix of I. Okay, this will be our answer. So just finally we return this array. Return return in DRR. Okay, let's see. I said how you guys done it correctly. If we are of zero, you cannot really slice this one. So there's popping some error. Okay. So why we getting this error? Why we getting this error actually? You see that because it's a the size is not defined, so it's null, and we are trying to assign the index of null vector. So we have to mention the size also. This could be signed as. So we don't need to push back then. We can directly assign this value now. Okay, like this way. Do it. Okay, let's see. Now we have to do this. Don't forget this index. Okay, let's see. So you can see the it passes. So to remember this syntax, okay. Sometimes you might occur. So let's submit our solution. Let's see what we got. So it's accepted. Okay, see this with 61%. Memory is like it's 76%. Okay, both are above 60%. Okay, good. So hope this solution is clear to you guys. Okay. Now moving on. Let's see now next question. Okay, it's very pretty easy, but yeah, you need some visualization. So you have solved your first medium level question. Okay, this one. Now let's see some second one like I've chosen you for you guys. This one. Common prefix. Okay. Let's see this one now. So what this question is saying? Find the prefix common of two arrays. Okay. It says you are given and two index integer permutation. Okay, permutation is given A and B of length n. Okay, so zero index permutation is given. The permutation is like 0, 1, 2, 3, 4, all the serial number. A prefix common array of A and B is an array C such that A of C is equal to the count of number of that are present at or before the index I in both A and B. What is line saying? Like a prefix common array of A and B is array C. Okay, so there is a prefix common array. Prefix like the array, some part of the array is make it as C, such that A of I, C of I is equal to the counts of number that are present at or before the indexing. Like C array will make a count like the how many elements are before the index I in both A and B. So it just prefix array will be the count of number of element. Okay, so we have to return this CF array. The sequence of integer n is called permutation if we contain the index from 1 to n exactly once. Okay, once should be given. Like these two. Now let's see the examples. Like these two example, like A is 1324 and B is 3124. So at I equal to 0, how many elements are common between these two? Okay, equal counts of number that present in both. So here number of element common is common element find it. So number of element common is 0 here. Okay, now suppose we index 2 here. Now look at these two. How many elements are common now? Two elements are common. Okay, so result is 2 here. Okay, now suppose up to 3. Take these three number. Okay, the three elements are common. Up to 4 number, 4 elements are common. Okay, so this is our result. Okay, you're getting it. Let me now visualize this because how gonna you suppose to approach this question. Like suppose let's take to both the array, paste it here. So we have to find C such that C will represent the indexing each indexing represent the common element between these two. Like like C of 0 will be common between A of 0 and A of 1, which is common between these two. What is the common element between these two? 0, no element are common because 1 and 3. So C of 1 will be what? Common element between these two subarray. So 1, 3 and 3, 1. How many elements are common? Two elements. You can put 2 here, and C of 2 will be similarly. You can put this 3. How many elements are common? All 3 are common. So 3. C of 4 will be all 4 elements are common. So what is resulting array here? Resulting array is like 0, 2, 3, 4. So now we have the array. So now we have to come up with solutions. So before that, let's me see the those you know and constraint. To constraint is up to 50 means you can apply 2 loops also. And but n square solution is acceptable as well as n cube solution because uh, so n cube solution up to we can approach. So let me just first show you the how we can approach this problem with the brute force manner. Like you can apply brute force here, like n cube is like brute force because it's not optimized with. So let's see that first, okay? We will understand the way. Okay, in this way we will understand it how to solve the problem. Like let's see the this is the question. Let's see the approach now. So how can you solve this question? So in one way, like you have to loop it through, and then loop through the B also. Like take one element of A, then take all the compare all the indexes till I index. So till I index compare it is common. Like suppose that this is the element given. Suppose so we have to take one and compare with each element of B, or you can vice versa also. Okay? So let me do this way also. So a one is compared with 3 not equal. Then we will move to pointer like 1 is equal to 1. Yeah. Then we can increment the count, like count equal to plus equal to whatever the count value was there earlier. Okay. 1. We have to increment 1. So and then store this in an array. Okay. If you store this array, then array will form or not. Okay. So in this case, the index is 1. So suppose the array is 2. So first, if you compare first two element, no element of common, so 0, 1. So this will be the resultant C array. Okay. So in this way, we have to perform this. Hope you got it. Like I have to make a comparison, make a basic comparison. So how are you gonna compare this to like you have to take every element and compare with every element of B till the first result will be like what will the first? First we have to traverse both the array and both array will be length will be same. It is given in the question. Na? See this. Both have same size. So first loop will be run from for int I equal to 0, I less than n, I plus plus. This will be the first element to traverse both the array. Okay, now we are into that array. Now we have to run one more loop, like one more loop for comparison of element of A with the element of B. So how we gonna do it? Like second loop will run from like for int j equal to 0, we will start from 0. And how many times you have to run? You guessed it. Like we will check up to the index, it is, up to the index that how many elements are common. So we will run up till I now. Suppose I will first I 0. So first two elements will compare. First element of A and first element of B. Now suppose I is 2, then first element of A and B are compared, and second element of I and B are compared because I is 1 here. So up till 1, we have to run this loop. So means up till I, you have to run this loop. So we have to do this like j is less than equal to I. Then j plus plus. This will be our second loop. Okay, this is our first loop. Now we are comparing the this will like comparing the number of A. Now we are getting array. Now we have to compare this to B. So we have to traverse the B array again. How much time? Up till I now. You guessed it. Like you have to traverse the now we are traversing this for A. Look, suppose we are traversing the A up to I. Then we also have to traversing the B up till I. Then compare all the elements of A with B now up till I. Okay, you are getting it. So we have to run one more loop. Okay, hope it is clear to you guys. Just visualize it. Firstly, we are traversing the loop, traversing both there. Then we are taking the element of A, first element of A. Then we compare with each element of B. So there are 3 loops involving here. Na? The first loop is for traversing both there. Second loop for the constituent element of A. Third loop is for comparing with B. Okay, hope it is clear to you. And k equal to 0 and k will be less than, don't make it I, okay? Don't make it j, you have to I, okay, remember this, because we up till I we just want the comparison, we don't want to compare all the elements. So up till I we can do k plus plus. This is the third loop, and in this loop what's you gonna do? You just increment the value of count now, and every for every I we have to make the increment count, means count should not be declared above. Okay, it will be like every I, like Suppose I is 0. So first element, how many elements are first zero first for first element in both, how many elements are common? Suppose I equal to 2, then three elements will compare. So on the three elements, how many elements are same? Then we are making an index and then we are filling the array C. Na? So we have to define the count inside this. Okay. Hope it is clear to you. Int cnt equal to 0. You can define this. So for each element, each time we are comparing, like suppose first time we comparing one element, then we compare two elements, then we compare three elements. So each time count have to be different, no? Otherwise the previous one will be added. So that's why we are making count here, initializing count here. In this way, after each iteration, count will be initialized to 0. Count will become 0. Okay. Now what's he gonna do? We just also need some vector like vector array, like like answer array. You can make it answer or whatever. So we have to just answer array. What do you have to do? We have to push back like So we will just complement the increment then we push back this result. Okay, this will be the way you create this array. Okay, so there are three loops. We have to close this one. Okay, hope this solution is very trivial. Like it is a knife based solution. So, but it's make you visualize the question. Okay, what the question is saying actually. So now let's uh, solve this question using the trivial approach. Okay, then I will show you some other method. So first we need the size of both. So we can just make like int n for a or b. Both the size are same. So you can let me do for a dot size. Anything you can do. B also. It's not like just like this. Now we need a loops. So we need a vector first. That vector we will be used to like finalize the answer. We have to return the array, na? Vector C. Like make it C. Like C vector we have to do it. So we don't need to define its size. We are pushbacking the elements. So its size will be calculated dynamically. So for int I equal to 0, I less than n, I plus plus. We have to run the second loop for taking the elements away. First loop is for traversing both the array. Int j equal to 0. How many times you have to run j? J till no equal to I, j plus plus. Then again run the third loop. For int k equal to 0, k less than equal to I, k plus plus. So we have all the three LS here. Now we have to increment the count. You can increment it or directly do it like c dot pushback cnt plus plus. So we need cnt also na in after I. Why we are declaring after I is clear na? Why we are declaring after I only? Because in every iteration count value will change. We are checking up till I only. The index I is changing every time. Okay, let's see. Let's see it is the approach base. So this is the third loop. After this we have to return this vector. Let's see. Checking or not first. Some semicolon is missing. Okay. Int I equal to 0. No? Okay. Silly mistake. Again something is missing. Okay, semicolon missing. Let's see. Something is wrong here. CN is becoming so large. This extra element are coming. Let's see, let's debug this. Okay, so it was like I'm doing a drawing it with. Okay, first we have to compare, then we then we only push the elements, na. So we are just making we have to compare first. So we have to make a step if statement like in the solution itself. I mistake quickly do this. Like we have to compare first, na. Like as I told you earlier in the question, but I didn't apply in here. Like first we have to compare this to na. Like if a of like if a of j is equal to a of k, then only we increment, then only we push back. Okay, this should be happen after comparison of this. Means if those elements are equal, then only push back, na. Like like a of j will compare with k. K will rise from a to k up to it will run up to 0 to I. So we have to make comparison first, then we push back. Okay, this is a silly mistake. You might guys might have done it. Okay, as I told in the solution, like we have to first compare now. Like A of J will be compared with if this element are equal, like B of K. Then we wanna do this, perform this line. Okay, so this is also so that's not now. Let's see. It should work now. So we don't compare and we directly increment it. Still getting the wrong answer. Okay, we have to do pushback after incrementing, the count. Okay, I got it. So we have to firstly increment the count first, like count variable will increment. Okay, then after coming out of this loop, like all the elements of B are compared with all the elements of one elements of A, like let's suppose this one, assume this one, like one, like we have 1 3 2, and we have 1 2 4 in B. This is A, and this is B. So we have to compare both these elements, both these arrays. So firstly we will take the A element one, then we compare with firstly the I is 0 here. Okay, I will be 0 first. I assume in that. So it will compare with this element only now because it will both the loop run up till I. So one and one is compare. Okay, so we have to first increment this value. Okay, firstly increment this value. Then all elements of when the all elements of B are compared, then after that you made the pushback. Otherwise it will be like we are comparing it one time, then we push back. Again we are comparing, then we'll push back. It will give a wrong result. Okay, like like for suppose example, like take I equal to now 2. So all three elements of I will compare with all three elements of B. Firstly, one will compare with 1, 2, and 4. So one is here. Like suppose 4 is here, then one. Okay, so one is compared with four, not equal, not equal, not equal. Then we are once we are equal, then we are just incrementing. After coming out of loop, we have to push back. Otherwise, it will be like one is compared with this and push back. Like zero will push back again, zero will push back again. Then one will push back. Like, suppose for example, array will be like 0, 0, and 1. Okay, three elements, but we want to push only once because one is only equal to one for one time. Okay, hope you got it, getting it. So this time we have to do it like this way. We just increment the count here and make the pushback after coming out of this loop. Okay, we don't need this now. So we need to look and do this directly. Okay, we were just comparing here to comparing the value. If both are equal, then only increment it. Then after coming out of the loop, you can do the pushback. So you have to remember this thing. Hope you learn from my mistake only so that you don't do the mistake. Okay, let's see now. Okay, you have to debug it also. Like yeah, I've done my mistake and I was like, okay, this should be this way. So once you know the approach, once if you doing the code wrong also, but you can debug it. Okay. See there, zero was pushed here, 0, 1, 2, 3. This should not happen. And that's why you're getting the answer wrong. Let's see now. Okay, we're still getting the wrong answer. It should be like above both the number. Okay, after comparing both the number, we should get the result back. So we have to do this like coming out of this loop also. Like we are comparing with A, okay, count will increment at this time. Then we'll increment a count. How many elements are common? Okay, we have to do this. Yeah, see. So this is the once you do wrong, but you have to also have to check the solution and try to debug it. Okay, so why we are doing it? Like let's get back into this and try to figure out by taking the first example, taking any example. This example only it's better. So like we are comparing each element. So if you push back like now suppose that we are push back after completing of this loop. If you do the pushback operation here, so what will happen now? One element is compared with 4 to 1. So count is 1 here. So count is 1 for suppose I equal to 2 here. I equal to 2, the count is 1 here, but not every element is compared. Okay. So every element of A should be compared with B. Then we have to find a common element. How many common elements are there? So how many common elements are there actually? 1 and 2 and 1 and 2. So 2 should be the final input. So after performing these two loop, we have to do the push step. Okay, you are getting it. Like the inner loop is like the comparing all element of B with the one element of A. Now all elements of A should be compared with all elements of B. Then we need the pushback because we have to find the number of element up till I. When up till I, how many elements of A are common with how many elements of B? Okay. So number of elements are common with number of element of B is declared by the up till I. So for that we have to run both these loop. Like first loop is comparing, first loop taking each element of A, compare with each element to be up till I, up till I. Then the count is final increment. The final value we have to push back. Like final value of count will tell that how many elements are common of A, how many elements are common in A and B up till I. Okay. So hope this is clear to you guys. Okay, try to visualize this. Try to take an option and see that why this pushback, why this pushback won't work, this pushback won't work, and this one will work. Okay, hope it is clear to you guys. So this was the n cube solution. You can see three loops are learning. Let's try to optimize this. How can you optimize this? So how can you optimize this solution? We have to look into this now. Okay. So let's see how we can optimize this solution. Okay. So optimize this like we have to make what is the first thing we have to first we have to run the loop. Okay, so I equal to 0, I equal to ln, it will be running. And for the second link, what we could do, like you can think of the logic, like you can create a map like something, or you can use map. Okay, so we have to use map here. So it's actually not part of array, but it's similar to array. Okay, like a frequency array, like like you define an array and you count the number of occurrence of the element, and then you maintain a count variable, and then you maintain one array. It's a similar thing, like indexing part. Like suppose you have in a book there, you have to reach to there is so many things written in like 500 page book. So using the index, we can reach the particular specific page. So in the same way, map works. Okay, you can read about maps like maps. Maps in C++, Java, not Java. So you can refer to this one only. So you will get so many things about map, how map work. Okay, so spend a couple of like 15 to 20 minutes here to try to read about this documentation and try to code it out. Okay, then you will understand the concept of map. Okay, put up this problem only. Anyway, I will be getting into the data structure map. Then I will get more detail of this. For now, just understand that we not much needed for map in this for question. You just need the basics. Okay, let's go through it and come back and look into my solution. So same thing we have to do. We can reduce one more loop. Like using this concept, we can reduce this loop. We don't have to compare every element of B. Like in the order of n square solution maybe. So how are we gonna do it? Like we need a map, and then we count the index, like 1 2 3. We will store the values of A, the values of A, and then it is a permutation array, so the element will not be repeated. So we can use map here easily. So values will be like 1 to 2 equal 1 and 3 equal 1 2 equal 2. And using the array B, we can get into the element of B. We can search for using the count method here. Okay, there was one method called count. You can use that count method to take the element of B and look into the map, whatever map we created for A. Okay, so this way you can reduce the solution, reduce the loops here. Okay, like suppose I show you the method. It is maintain mentioned somewhere. Like yeah, it is not it is count. Okay, count method. Look into the count method. So count method built-in function which is return one if the element with a key k is present in the map container. Okay, so we create a map for A, like whatever element are present in A, we will create a map for this. Then after that, we will search the each element of map using the count. So we will create the map. Then in the same time we compare those elements. Like I up to I we needed only, no? So up till I we can count easily. Like what? How can you do it? Like visualize this for you. Like like element, and suppose the array is like, what is the array? Array is like 2 3 1 and 3 1 2. Okay, so A is like 2 3 1 and B is 3 1 2. Suppose. So what you're gonna do? We can create a map for A. So once we traverse the way, like I equal to 0 to n, we traverse it. I equal to 0 and n, we traverse it, and we create the map and compare those element only. Like for J we will be running a loop like J equal to 0 and J less than n and J plus 1. We run a loop and take the elements of A and create a map for every time. Like for J, uh, J is less than j is less than equal to I na. So map will be like size m only. So how to create it? Like MP, you will take a map here, like you will declare a map. So it's needed two things: key and index. Key will is a reference to the number you are referring to. Key will be here integer only because the numbers are integer, and in this way you can just second element is used to store the value MP. Like you can directly reference to the MP of like MP, you can do A, we will just increment this. So final map will be for this I equal to 0. Suppose I is equal to 2 here. Suppose I is equal to 1 here only. Okay. So map will be like 2 will be created and its occurrence is 1 and 3 will be created, it will occurrence is 1. So you see the map we needed. Once we create the map, we can directly compare the map also in this loop itself. Like for j equal to 0, j equal to 0, map is created and we compare the map. Like is the element of B. Like suppose we'll take like MP dot count, we'll make the key as b of 0, b of whatever the index, like b of j. So it will compare itself here. If like if mp of this, then we what we gonna do, we increment the count and we just push back the result. Okay, so in the same way we have to do the count. Like if mp dot count, it will return a pointer here, no? See this, what's the return actually, what's the return type of this count function here. Then set count 1. So it's a boolean value. So if it's present, then the check condition is true. If it's present, like b of I is what? Like suppose 2 up to. So b of I will compare. Firstly, this will compare. If 3 is equal to 3 is present here in the loop. Yes, 3 is present here. So we'll count, increment the count. Then again the loop is run. Loop will be run. Firstly, the map will create it for this only. Then we made the comparison. Is these two are equal? No, because we are taking the ith element of B. Then when a size of 2, the map will be created like this. Okay, so 2 and 3. So each element of B will compare also to element is 1 here. So is 1 present? No, only 3 is present. For this part, only 3 will be present. It means in 2 up till I equal to 2, only 2 elements up till I equal to 2, only 2 elements are common. Only one element common, like 3. So count value will be 1. So array will be like 1 first. Okay, so in this way you reduce to one more loop, like only n square solution is. So we have reduced exponentially, polynomially, we reduce it by one time index power, like n square to n cube to n square limit. We reduce one loop. So let's see how you implement this. Okay, hope it is clear to you guys how we are using the map. Map will create a index of this array A, like basic for naive example, and the B will take element of B and search in the map. That's the thing we are doing only here. Okay, let's see now. Let's see the is the solution. Okay, this one. Let's see. So we don't need this loop now. We need these two loops still, and we have to create the map. So where are we gonna create the map? Like we don't need to create the map every time I is running. Okay, for I is equal to 0, I is equal to 0. Okay, I to 0. You have to create a map here. So every time map will be created, like not before I. If the I before created, then the previous one will taken, like again whatever I explained earlier. So you have to create the map. You can take in unordered map because we don't need the order is not unordered map will don't count for the order. Okay, unordered, so unordered or unordered. I forget unordered. Okay, so unordered map. I have to take this map. Let's see if it work or not. I will change it if not work. On a lot of maps, we have to take two elements, int, int for one for key, one for value. Okay, let's rename it. Next, let's give it like mm, name like what we are doing with this map. We are doing basically the comparison with the CMP. So once the map is created here, once you run, you create this map CMP of one whatever a of j na. Each element of j a is making in the map, and then we are making the comparison. If cmp dot count you know b p of I is present in this solution, then only we are incrementing the count, and after coming out of the loops you remember just push the values. Okay, let's see if the solution work or not. If not work, then I will debug it. Okay, don't worry about it, but it should work. Okay, we are getting wrong answer. It's not correct then. Okay, I think The map is declared again. Then again these values are given. Okay, let's declare this map outside. Maybe this is causing this. Still getting the wrong answer. Why this is happening? Okay, let's debug. Okay. So what's get wrong here actually? So actually the yeah you declare the map. You have to create the map itself here. Like once you every time you run, just create a map. And this is wrong. Why this is wrong? Like suppose why this is wrong. Let's debug this. This solution is wrong actually. So if you increment the j here, like suppose you have incremented the created a map here, and we are checking the same line. So like this is like map is already there. Then j time the map is incremented. So again when the I is incremented, like I suppose is here 0 here. Firstly here j equal to 0 0 1 map will created. And again if the I is incremented again two times, then again the map will created here. Okay, like again the map will created here I equal to 2 and I less than equal to j equal to 0 to 2. So again the map will create it from again from beginning. Okay, so you're getting it. So actually what is happening here, like what is happening here? So I is here, I is here 2 now. So this loop will run till 2. Then the map will create it again. Okay, see this is the difference. If you created a map in a one go, like once you traverse, you create like 0 for 0 1 you covered this 0 1 1 0 1 element, then 0 up to 3, then cover 3 element like this way. So you have to create the map period to the comparison. But if you do this way, what will happen here, like the map will created for the first time. I equal to 0 map will created here like this. Okay, this will be created, and then a comparison is made. Okay, now I equal to 1. If I equal to 1, then the map will created again. So we will take this element, we increment 2, and then we are still comparing with this. So but I equal to 2, these two elements should be there. No? Means each element of A, each element of A should be compared with each element of B. This is the issue here. But in this part only one comparison will be made again. Okay, one comparison will again it will return 0. But both elements need to be compared simultaneously. Okay, for that purpose we have to increment this before the you know before this only. So if you create a map here now for I equal to 0 and then compare, okay, I equal to 0, if this element is present in this, then increment the count. Then I is incremented, then the I is incremented 1, then I equal to 1. So it will again means one time the map will one after another the elements of A will come, and it is for each element of B we are comparing that, we are doing also here also wrong. It should be J, not I. Okay. So we're comparing the elements of each element of B, na? So which index should be J. Okay. Let's see it's gonna work or not. So B of I. Okay, now it's correct. So you see that this solution are accepted actually. So this is the logic. You have to work on the logic. Okay, the it is taking too long because I'm done so many mistakes. Like you need to visualize this first. Okay, but it's like I have just read the question and think of the solution. Now implement it in front of you. So something might would have happened. Okay, because I haven't solved this question earlier. I'm just try to think. Just I have read this question and think of a solution. Okay, this will like visualize in my mind that this solution will work, but I haven't implemented it. But now I am implementing in front of you, so this is happening. So, but you have to understand this. Okay, you just create a map and then maintain the map. Then we compare the each element of B with the element of A. So this is the perfect map solution. If you declare map inside the J element, when means the map will created and updated every time, and it can be ambiguous result. It may lead to ambiguous result. What we are seeing right now. So okay, now let's now submit this problem. Okay, so it's working. Okay, you haven't submitted the first problem, n cube solution. Okay, let's do the n cube solution. So I forgot to submit it. Like n cube solution should also work. Okay, this memory is more because we are using a data structures map here. Okay, So if you try to do this, like, suppose I haven't had the map. Okay, let's submit that one also. Let's see the comparison. Let's remove this back and just bring the loop also. Let's see, like, in k equal to 0, k less than equal to I, k plus plus, if if a of j equal to b, b of k, where implementing the count, you will understand the difference here. Okay, okay, let's submit this. Set it in our, let's submit this. You will see the difference here. 38 millisecond for map. Let's see why n cube solution. It's nearly twice. See, it will be twice. Okay, see 38 to 89. So see this. So this is the power of time complexity. Okay. So if you get it now. So now if you submit this, it will 38 seconds now using map and without and keep solution taking more. So you have to taking care of this way. You have to visualize the question. Like, you know, one time you try to firstly come it with any solution, brute force solution if not working. Then try to minimize this if possible. Means if the constraint allowing you to do brute force, you can try brute force. Then try to optimize the solution. Okay, like I've done here. Okay, hope it is clear to you guys. This session might have taken so long, but yeah, you need to understand this. Okay, let's now see some last question for this today, and let's end this session. It's taking too long now. Let's see the third question what I have chosen for you guys. Okay, let's see. It's very interesting activity. I've read it like, oh, it's networking question actually. Not fully networking, but if you like networking, you can relate it to. Okay, let me explain this and let me solve this question. Like, what's this question say? You are given you are given a log of users. Okay, the data of user action on Leetcode. Okay, how many users have done login, logout, and integer k. Okay, k is given and logs is given. Logs are represented by 2D integer array logs, which represent the log of I is ID and time. Okay, indicate the user's ID and perform action at minute team means the logs is given as the user. This user has performed this operation in this given time. This is given as a two-dimensional array. Okay, multiple user can perform action simultaneously and single user can perform multiple action in same minute. What does this mean? Multiple user can perform action simultaneously. Like suppose the three user are there and both are on all the users are submitting the questions answer of solution of questions simultaneously. This could happen. And single user can multiple action also. Like he can review run some program at the same time, can submit the program at the same time, debug the program like that. Okay. So the user active minutes UAM for a given user define a number of unique minutes in which the user perform an action or lit code. So the user UAM for a given user define a number of unique minutes in which the user perform an action or lit code. The minute can only be counted once, even if multiple actions occur during time. Okay, multiple action means suppose that user do something in 5 seconds, 5 seconds, so 1 5 will be counted. Number of unique minutes in which unique minutes is given. Na? So suppose that the same minute can only be counted once if the multiple action occur during that. Means suppose the user have done multiple action as done in this part of the this sentence. So only one will be counted. Like suppose 5 5 on 5 minutes he have done two tasks. Only 1 5 will be counted. So both 5 can be given. Okay, logs is defined that way. Okay, this is mean by this statement. You have to break this problem. Okay, so much. So you have to calculate a one index array answer of size k. So size k is given. So you have to calculate the answer k such that for each j belongs to 1 to k Answer J is the number of user whose UAM equal to J. Answer J is the number of user whose ARM equal to J. Suppose answer 2 equal to 2. What did this mean? This mean that this is how the 2 like answer 1 equal to 2 like that. So answer of 1 equal to 2. It is mean that one user has no two user have UIM of equal to 1. This is that means it means answer of 1 equal to 2. This mean that 2 in this mean that two user have UIM equal to 1. Okay, this is mean by this sentence. Okay, return the array and describe. So examples is given. Let's see the constraint first. So yeah, 10 to the power 4. You can learn only one order of n solution is required at least. So at max. So time is given and k is the range maximum UIM for user. Okay, at 10 to the power 5. So this is given. Now, hope you guys have understand this line. This line is very important. This line will derive your solution. And rest is like, you have to figure it out. Like the logs are given first. Let's see an example, okay? And we'll explain. So this is the array given. Okay. This is the array given. So as you know, all that the first is the ID of user, and the second part is like the time spent or UAM. You can say that. Okay. UAM of the user. So as mentioned in the question, like this one, action performance minute T, active minutes. Okay, so this is given. So we have given the element k. Okay, so size of array will be our k size. So what will be size of the array? So we will have 5 elements in this array. 1, 2, 3, 4. So indexing will be like 0, 1. It's a one index array. Okay, this is also given. Like, so one index array, 1 to k na. So it's a one index array. So remember this point. Here is written. So 1, 2, 3, 4, 5. Okay, this is the array. So how the this array will fill? K size is given 5. So we know that each a of j will be Let us say question say is the number of user whose AOM equal to a number of user you know whose UAM equal to j. So you have to fill this with like a number of user whose OAM equal to j. So first see the user 0, 0, 0, and 0. So user 0 has three data, three UIM. So 2, 5, and 5 will also contain, but only the unique value is contained. It's already saying. So 0 ID means user have this many, time or UAM. And for ID 1, we have 2 and 3. Okay, see this 2 and 3. So this is the data we have given. So how many users like the number you have to fill this index now to number of user whose UIM is 2. So the two number of user how many users like 0 user 0 have UIM 2 and user 1 have UIM 2. So how many user have UIM 2? 2 user. So 2 user J is UIM 2 represented by this index. So this is the UIM. And how many users are there? So only 2 users have the UIM 2. This depend user na see number of user a of j. So this is 2 is the number of user whose AIM is 2 and rest will be 0. Okay, so this is the case here. You can see the array is formed like let me show the example. Let me show the output. See in a similar manner this is also formed. Okay, like 1 1 2 2 2 3 and k equal to 4. So this is the way you work. Okay, so let me take the another example also so there is no confusion. So now the k is given as 4 here. Okay, k equal to 4. So we have to create a 4 digit array. This is one index array. So 1 1 like there are two 1 1 means one user ID have the value of 1 only. Okay, and two user have the UIM value of 2 comma 3. So now in this case suppose so one user have the UIM of 1 means a of 1 should be 1 or not because one user have UIM of 1 and now one user have UIM of 2. Okay, see here. So array of index will be 1 here. It will be 1 here. So you have 2 f1 and you have 1 is 1. So what are you gonna write here? Finally it will be 1 and it will be 2 and rest will be 0. Okay. So hope you're getting it. Let's see. So it will be 1 actually. So it will be 1 na? Sorry, no, it will be 1 because both values 1. Sorry. So let's see the solution. So yeah, 1100. Okay, so we are correct. Now approach. How are we gonna solve this question? So you guessed it, might have guessed it from my explanation also. Like how are we gonna solve this question? So how are we gonna approach this problem? Like we have given array like the one first will user have the value of 1 and second user have the value of 2 and 3 like the previous example I'm taking. Okay, so what do we have to store? How gonna do it? We just give an array like array was given like this now, like 1 1 and 2 2 and 2 3. This is the two-dimensional array is given. So firstly, how you gonna access this two-dimensional array? So this two-dimensional array, see that the number of columns are always two, the first column and second column. If you imagine this way, like 1 1 2 2 3 3. If you imagine in a matrix way, so all this the two columns are two and this can be anything like row can be anything it up to 10 to the power 2 but columns are two. This thing you have to remember. So in this way you have to firstly access this array and you have to create like to associate the values like first element have how no first user UI have how many UIM. So you have to store this one. So you need a data structure. So you need a data structure to store this one. Okay, so how are we gonna store it? So if you figure it out, then the solution is easy. That once you store this, just you have to count these numbers and just fill the array accordingly. Okay. So approach can be like take a map and store the value. As we've seen earlier that I've been talking about the maps also. So you can use map here. So now the problem is how we gonna store these values in map. So like values can be no like like it's given in the previous question like user 0 have two values now 5 2 time like 5 2 time it have. So you have to store only once. So you cannot take an array and create one map of integer and one map of array to store the element because duplication is there. So you also have to remove the duplicate. So how are you gonna remove the duplicate? So we can use set here. Okay, so we can learn set from uh, so you can learn set from the same library. Okay, so you can store a set or set which is element to be unique. So this is the characteristic you are using, and this is the syntax. Set data type and set name, and we can use insert operation to insert the element in set. So always the unique element will be stored. So considering this in, now we have to design the solution. We have to take the map. So map will be unordered. So you can take ordered map also means map only. Order is not necessary in an importance here also. But you don't. It will be in an extra complexity like ordering. So ordering requires some time. So better to take unordered map. Okay, unordered map is best here, like the previous question. So unordered map. So we have to take int. First data type will be int, and next one you have guessed it. It is set. Set type data we are storing now. Only the unique value will store like 5 only for this. So we have to take set data structure. So integer data will be integer type of set. We have seen the how to declare set here. So you can name it MP for now. Okay. So this will be our map. So using this map, we have to work on our solution. Firstly, you have to what are we gonna do? We have to traverse the two-dimensional array. So we just traverse once, like for int I equal to 0, I less than the size of the two-dimensional array, the number of elements in array, and I plus plus. So this is the loop we have to run. And inside the loop, what you're gonna do? You have to fill this map actually. So how are we gonna fill this map? So as I have shown you, the number of row will be varies and number of columns is always 2. So the number of column will be 0, either 0 or one index only, na? But it can vary. I will vary up to 0 to n. I belongs to 0 to m. 0 to m minus 1 actually. So it will vary till this. I will vary till this. So you have to create the index like MP. How gonna fill it? MP of a array A is given. Array A, suppose the logs is given to array A, and let's suppose A is taking. So we have to take the I will be here and column will be 0. Why 0? 0 column will have the user. Na? This is like 1 and 2. So this is user. If you remember this is user actually, user ID, and this is the UIM, the unique whatever the number, the time. So first index will say I of 0 is the first index or not, because it is A of 0. This way you design your column A of 0 0 and A of 0 1. So this is our matrices first row. So 0 0. So for that I will vary from 0 to, and again so on the arrow will remain, but column will remain. So you have to create a map, like you have to create a user map, and how many UIM it is, unique UIM it has. Suppose it had 2 3 3, and you're gonna store 2 3. So we have to insert the element in the set. So that's set, this set. You have to insert, and this is the way you have to do it. Okay. Insert. What are you gonna insert? You have guessed it. The second part, the UIM. So how you gonna access this element? A of I and 1. No. Okay. Now this is clear to you guys. So this way you will create the map. Okay. This way you create the map. Firstly, you have to create the map for every element. Okay. Now what you have to do? Just you have to Now what you have to do? You have to traverse it and insert it in array. That's it. So it's very, the problem, it boils down to pretty simple thing. Okay, just you need to take care of this. It's an implementation based problem. Okay, nothing else. So how are we gonna do it? We have to take a vector. So vector, vector of integer, and the vector name, suppose like race or something. You can do whatever. So the vector is indexing from 0. So we have to taking care of the action this. So how we gonna implement this? Like vector of rest will be indexing from 0 to, but we have to we have to create the index from 1. So how are we gonna give this as, it feel like a one index array? We don't need to print the index, we need just print the array. So but we are storing it as a one index array. So how are we gonna make this? So firstly we have to run a loop. I have shown this loop, we have seen like auto I. Where we have to, you run the loop in the map auto I and MP. What's you gonna do? We just have to raise of whatever the size of this number. This size give the number of UIM. So we have to store the number of UIM and the increment every time, whatever we come. Like this way the array will happen. So the most 2 is there, and it's a 3 5 7 something. Okay, so every time it is your we have to store size minus 1, and then we have to increment this. Why? Because it's a one, we need a one index array. So if you stored the UIM 2 is here, and if we are actually we have to iterate over the second element. Okay, the size of second element is this one. This part is the map first element, this is the map second element. So second element we have to get the size, and this just size minus 1 for index, and just increment the index, like like uh, like this is 2 here. Okay, so how we gonna make it 1 and 2? If you directly put size only, it won't increment. Like it will be like just size will firstly 2, but the size we have to make uh, uh, so what's the element? We are counting the element here. The first element, second element, and third element, like this way. So first element have the have the have first element have the have number of UIM is 2. So we have to make the result in such a way to have to put the UIM here, and UIM, you have to increment the UIM. So how are you gonna do it? You have to do it like this way. Okay, I dot second dot size. It will give the size of this element. Size of this index size. You do minus minus or size -1, then increment this part every time. The loop is run. So what's it gonna do? It's like first element we considered, then the array of size will be incremented. And the second element we considered, an array of size is then incremented. So first like size minus one will be what? Size minus one is will be one, and one is there, and we increment it to two. So so in this way, we are making this value. Okay. So I will be first I of index of I of index -1. I of index -1 give the number of UIM for particular index. So like I of second is like 2 and 3. So it's 2. So firstly 2 minus 1 1. 1 will be incremented here. Okay. In this way we have to fill this array. So what's he gonna do? We directly have to push back this in the array or not? We have to push back this in array. So what's we have to do? We have guessed it. We are creating the index of arrays of, and we are filling the simultaneously. Okay, this line is creating the index here. Okay, you're getting it now. Like this line is creating indexes. So let me run this for loop once. So this is the map. This is our map. The first element is you have to create the index first. No? So element of size -1. Size -1 is 1. So 1 is incremented by 1. So one index was incremented by 1. So we have the means one element means array of 1. So array of 1 size -1 is 1. Array of 1 plus plus array of 1 is storing 1 here. Okay. So and the array of then what's we doing? We just simply the size -1. Then you increment it. Then we get the one index part, and then we got the values. Okay. So size of I -1. Okay. This way you have to make the means array. The index is actually 0 now. So firstly the index is starting from 0. So first element. So this array have index of 0. So we have to make the index as 1. That's why we are decreasing size, then we incrementing the value. So in this way we are filling this array. Okay, let me up let's now implement this solution, and let's see, you will get it there. Okay, let's implement this now. So what's the things we need? First we need the address of this in 10 equal to log size of this array. Actually we need the size, and then we need the vector where we're gonna you know return this vector res, and it will be of size k, and firstly the initialize each element to 0 so that we can increment each element and fill the values. Okay, so this is clear. Now we need a map, as we discussed. ORDERED, unordered map. To take unordered map, the first element is the user ID, so it's only integer. Second element is a set of the UIM value, unique value, so it will be set. If it is clear, just MP. So what you have to do, firstly to create those the storing the each value, each URL for user. I less than n, I plus plus. We're gonna store like MP of where you gonna store the log size, logs of I and 0, as we've seen. Dot insert what's you gonna store in this set? The logs of I comma 1. That's it. So in this way we formed a map here, and if you look into the map it will be given that way. Now we have to run a loop to increment the array, means fill the element according to the element and just display those array. So for auto I in MP, what's it gonna do? We just make the result index of result as I dot second part is the set of element, I dot second dot size minus 1, and we increment this value. That's it. It will fill the index accordingly. Okay, and then we finally return the index, return the result. Let's see if it's working or not. Okay, it's accepted. Okay, see how we get this output actually. It is actually in the first element, but it's we have to make it second. That's why we're incrementing the value. Okay, so if you remember the first example, it have the first element have two elements have the two elements have the UIM of two. So we have to fill that way. You know, as the question is saying, like is a number of user whose EIM equal to two. So UIM you have to make it two. So UIM like two value. The first index have two value. Like first index, if you remember, one has and zero has the zero 1 3, and one has the 2 3, and zero have 1 5, and the second element, the one element have the it has 2 3. Okay, so firstly the first element will consider its size is like 2 minus 1 1. Index 1 is filling here. So this is index 1 only. This index 1 is incremented. So it is incremented for 1. Okay, where is 20%? So is this element incremented by 1, decrease and incremented by 1 to we get into the first index. Actually, it's a second index, but you have to make it, we are in the first index. So that's why you have to use n minus 1, size minus 1. So where in first index, then we increment, then we again go and check that okay, there are two again. The second half size of 1 2, which is by decrement 1 by 1, and we plus it, we increment it, so it will become 2. So size index of 1 is actually 1, but it's in the array it is 2, na. Okay, you're not getting it. Like like here it is 1 bit in bit, but in actual final array it is actually 2, na. So a of 2 is equal to 1 basically. So in this way we are doing it. Okay, you are getting it, like so here in the case of this element, so firstly this one is like index of 3 minus 1 to a of 2 should be equal to what? It's equal to 1 now. It's incremented by ones only. So in this way it's filling like, so it is 2, but in actual it is 3. So final is that suppose k is equal to 3 here in this 4. Imagine 4. So first size 1 is 0 element here. Size 2 1 element. Size 3 1 element. Size 4 0 element. Size 5 0 element. So this is the way the array will fill. Okay. So this way, that's why that solution work. Okay. Hope this is clear to you guys. If it is not clear, please refer to my explanation. Again, I have explained you here. Okay. Okay. Hope this is clear to you guys. Okay. It's just understanding and implementation part. Nothing is there. Let's submit also. Okay. 88% has been. See, solution is pretty fast, 90%. So that's all for today, guys. Hope you have hope you have gone through this lecture and understand the codes that I've given you. We have need to practice lot more practice. Okay, if you are a beginners, then solve more easy question. Then come into this medium level questions. Okay, and if you are a medium level user, like you have intermediate candidate, then just look in at solution, how I'm implementing solution, and try to visualize this. The most important is visualize this. Take a paper and pen and do the way I am doing it. Okay, in this way you will visualize this and you will be easily able to solve any problem. Okay, so for this, that's all for all today. Hope I can bring the other. I will bring now another lecture on which we will solving some hard problem. Then I will teach you recursion. Okay, it's another way of programming that's needed in the data. Thank you for watching it, guys. See you later. Bye. Take care.